Hello, my name is Carl Cook and I'm President and Chief Technical Officer of Biocomp Systems. And in this video, I will show you how to create a moving average crossover system for Biocomp Dakota. And we'll do it in 15 minutes or less. First thing to do is start up Visual Studio Express 2012 for Windows Desktop. And we'll create a new project. We have a choice of using Visual Basic or C#, but we're going to create a class library. And we'll name that My Moving Average. And click OK. This will create a default project, and we'll need to make some changes to how it's configured so that it's compatible with Intellect, the infrastructure underneath Dakota, and Dakota itself. The first thing we want to do is target .NET Framework 3.5. Then go to References and add the Intellect DLL, which, if you followed along in the last video, should be in your recent reference list. Click OK. Also, when changing the .NET Framework to 3.5, we want to turn off this system threading.tasks. I'm going to click Save and close this. I'm going to change the class name to something. It doesn't matter what, really, but I'm just going to call it My Moving Average. And then I'm going to inherit a bot object which will give us a bunch of functionality. So I will type inherits intellect.adaptation.bots.bot. Now we have a lot of functionality. Now the first thing we need to do is give this baby a name and a description. So I'm going to do public sub new, which is a function that's called, that's a subroutine that's called each time this object is created. And I will say name. There it is in the list because it's a part of a bot. Name is My Moving Average. Boy, I'm having a hard time typing. And I'll give it a description. There it is. This computes moving average. Good. Now, moving average crossover system that I'm going to create has two parameters. So I will call a function called create parameter, and I'm going to say that it's type double. It could be type integer. That will work too. And then I'm going to give it a name, long moving. This is called long period. And I don't need to give it a description. And there's a min, max, and an initial value. The min and max can be overridden by the user in the user interface, the user being probably you. And the value will be probably changed by the initialization function, but we'll give them anyway. So let's say the long one goes from 200 to 300 with an initial value of 250. And then the last parameter of this create parameter function is whether or not it is adaptable or not. And yes, it is. And I'm going to do a shift home to select it all because I'm going to create the short moving average period. So we'll call it the short period. And let's say that that goes from 20 to 100. Oops, 100. And let's just say it starts off at 50. Good. Now, to make use of these, and I'm going to step ahead here to public overrides. We're going to override the create signal function of the bot object that we inherited here, and we don't need this. So we take it out. Visual Studio puts it in there for us. And what we receive is, what this is called, this create signal function is called every time a signal needs to be created by Dakota, each bar. And we receive data in row column format, which is double precision floating point numbers. And we're expected to return a double, which is the signal. Now the data is columns, which are the data series coming in. So that's going to be date, close, or date, open, high, low, close, or whatever you're feeding this guy, including whatever is the result of your functions that you have applied in the indicators tab. So this is transform data that's coming in. If you don't have any indicators in the indicators tab, it'll be the raw data coming from whatever the data source is, text file or metastock or formatted data or whatever. Now, we need to be able to create and get those long and short period from the parameters. Because those parameters are adapting, those numbers are going to be changing. So the long period is not going to be 250. It's going to be something between 200 and 300 inclusive. So we dim long period as, we can say double, or it could be integer, equals parameter, let's just say parameters 0, which is the long one. It's the first one, which is their base 0. Just gets a little confusing. Parameters 0 dot value. And rather than typing, I'm going to select this text and I'm going to get the short period and out of parameter 1. Now there's another function in here too, which is parameter value, where we can also give the long period. You can give the name or the ID and it'll return the value back. But there's a lot of different ways to go get the parameter value. I'm showing you one of them. So then now we want to create the long average and the short average and then look at where they are with relation to each other. So I'm going to say dim long average as double equals, and then I want to get the current value of a simple moving average. So I'm going to say, okay, because the current value is what's at this current bar of the simple moving average of the data. And what column do I want to use? Ooh. Are we trading the open? Are we trading the close? Is there one column? Is there 5 columns? Is there 8 columns? Oh, how about, I would like to have the traded, oh good, there's a traded column ID. And then the period of the long average obviously would be the long period. And we can calculate theoretically the entire length of the series, or just that which is sufficient to determine what the current value is of the simple moving average. So there's a look back, number of rows back to compute this simple moving average. So for performance reasons, we're going to say just compute it back the length of the long period so we don't end up wasting MIPS. So now we have our long average, and I'm going to copy that to save typing and say short average, and then I'm going to, that only needs to be computed for the short period and looking back the short period. And then if the short average is greater than the long average, then probably the market's rising, so we're going to return a 1. That's greater than 0. A positive number means go or stay long. If the short average is less than the long average, then return a, oops, I meant to hit a -1. That would mean to go short or stay short. And we're missing one condition, or they're equal. And if they're equal, they'll fall through that two pieces of if statements. And so we just return 0. Go out. 0 means go out or stay out. There we have it. But we have one more thing to do. The data that's coming in, unless we specify a look back, a maximum look back, the data that's coming in will be a single row. Yeah, that's appropriate for real-time things, perhaps, or other situations where you don't need to have a history coming in. The data that's coming in is not the entire length of history. It's what we tell it to deliver to us. So we will override another function. Public overrides initialize. That's called when this guy is about ready to go in Dakota. Just before it starts firing off stuff, it will tell everything to initialize. And what do we need to do? Well, we need to tell the system what the maximum look back of the data that we need. Now, you could say that straight away, but we're going to do this. Watch this. If this guy is greater than this guy, then. So if parameter 0, 1 is greater than parameter 1's value, oops, I want the maximum. That's the most this thing can look back. Then we want to set the max look back equals to the bigger one. Else, max look back is equal to there. Now that tells the Dakota engine, the swarm engine, that you need to provide me at least this much data in order for me to be able to compute my moving averages. When the data is coming into the crate signal, it will be of this length back in time. And that's going to be based on the maximum possible look back for the long or the short period. Now, why can't it just figure it out? Because we created two parameters here that are optimizable to have a look back. And it's only in this case that the parameters that we're creating are in fact time periods back. We can create other kinds of parameters that adapt that have nothing to do with look back. So Dakota cannot deduce it just out of the parameters on its own. That it must be told to do so. You could, if you wanted, put a max look back in here of some fixed value, but if you like just punch it in as being 300, but if you go and change it in the user interface to 400, then you're going to get into situations where 300 is not enough, and then you're going to end up not getting a signal because it can't compute the moving average. So we instruct it how to do that. So now we save and build this, and we're going to go get this guy, and we create him as a debug. Now we're going to go over to Dakota. Uh-oh, I'm running up to 14 minutes. And I'm going to open this guy up, and here's our moving average, or our bots. And I'm going to add in this guy. There's the DLL. Ignore all the other stuff that's in there. And there's my moving average. So I'm going to put it under custom and click on it to set it as being my signal generating thing. And here's my two periods. Now I'm going to go over and I'm going to get some data. Coco, double click, mind your dates, and click go. And zooming along it goes. and we have a signal, and we have our periods. Now that went kind of fast. It only took a few seconds, so I'm going to slow this chart down. This chart's kind of slow, and I'm going to go back to the Swarm tab and click Go again. It's a little slower, but now we can see these guys, whether or not they're profitable and moving around within the Swarm's space, parameter space. You'll see it says long period and then also long period and short period. That's because we only have 2 parameters and it's throwing it into a 3D space. And you can see that this guy runs kind of slow. If I slide him over, he goes a lot faster. That's because of this chart control. We're going to get rid of it. So there you have it. We created a moving average crossover system, a new project. We compiled it. We left it as any CPU and debug. We changed it to .NET 3.5 so it'll load into Dakota because it's compatible with the .NET architecture. And we wrote our bot, we compiled it, we ran it in Dakota, and we did it pretty close to 15 minutes. We're at 16 minutes and 17 seconds. So I appreciate it very much, and thank you, and stay tuned for more videos to come.